Hello students, this is our 8th session of chapter 4 data structures. In this session, we are going to study about two-dimensional arrays. So what is a two-dimensional array? A two-dimensional array is a collection of elements and each element is identified by a pair of indices called subscripts. Consider an array A of 3 cross 3 matrices. So here A is the name of the matrix and 3 cross 3 is called as subscripts. It is nothing but the pair of indices, that is m cross n. So here m represents the number of rows and n represents the number of columns, The number of rows and columns in a matrix is called as the order of matrix. The number of rows and columns in a matrix is called as order of matrix. The number of elements can be obtained by multiplying the number of rows and the number of columns. The number of elements can be obtained by multiplying the number of rows and the number of columns For example, consider this array elements. So in A of 3 cross 3 matrix, I am going to store the elements, that is 10, 20, 30, 40, 50, 60, 70, 80 and 90. So these are the array elements. So how to calculate the number of elements in a matrix can be obtained by multiplying the number of rows and the number of columns, that is 3 into 3. So 3 3s are 9. So in A of 3 cross 3 matrix, I can store 9 elements. So this is how we can calculate the number of elements in a matrix. 30. So what are the positions of is A of 0, 0. A of 0, 0. What about 20? A of 0, 1. What about 30? A of 0, 2. What is the position of 40? The position of 40 is A of 1, 0. A of 1, 0. What about 50? A of 1, 1. What about 60? A of 1, 2. What about 70? A of 2, 0. What about 80? That is A of 2, 1. A of 2 cross 1. What about 90? A of 2 cross 2. So what is two-dimensional array? A two-dimensional array is a collection of elements and each element is identified by a pair of indices called subscripts. The number of rows and columns in a matrix is called as the order of matrix, and the number of elements can be obtained by multiplying the number of rows and the number of columns in a matrix. Now let us see how to represent a two-dimensional array. Representation of two-dimensional array. Suppose A is a matrix of m cross n. Then we require m cross n memory locations to store the array elements. So here we can represent the two-dimensional arrays in two ways. That is, first one in row major order and second one is column major order. Second one is column major order. So what is row major order? So consider this matrix, that is A of 3 cross 3 matrix. So in this matrix the array elements are 10, 20, 30, 40, 50, 60, 70, 80 and 90. So here it has 3 rows and 3 columns. Now let us see how to represent these array elements in row major order. In row major order, the elements of first row are stored in contiguous memory locations, then the second row elements and so on. So see, in row major order, we are going to store the first row elements. So what are the elements of first row elements? The first row elements are 10, 20 and 30. So I am going to store, these are the values, memory address, and then the positions. So what are the first row elements? The first row elements are 10, 20 and 30. 10, 20, 30. So what are the positions of 10? The position of 10 is A of 0, 0. What about 20? A of 0, 1. What about 30? A of 0, 2. It is 0 cross 2. Next, it will store the second row elements. So what are the second row elements? The second row elements are 40, 50 and 60. 40, 50, 60. So what are the position values of 40? The position value of 40 is A of 1 cross 0. What about 50? A of 1, 1. What about 60? A of 1, 2. Next, it will store third row elements. The third row elements are 70, 80 and 90. The elements are stored in contiguous memory locations. So what is the position value of 70? The position value of 70 is A of 20. What about 80? A of 21. What about 90? That is A of 22. So consider the first value stored in memory address 2001 order . So this first address of the element in an array is called as the base address. It is called as the base address. So this is how we are going to represent the array elements in row major order. Now let's see how to calculate the memory address of any element in an array. So there is a formula for that. So what is the formula? The formula is location of A of I into j is equal to base of A plus W into n into I minus jb plus j minus I minus lb, that is lower bound, plus j minus lb. So this is the formula to calculate the memory address of any element in an array using row major order. So now let's see what is base of A. Base of A is nothing but the address of the first element in an array. Then W is the word per memory location. It represents the word per memory location, and n represents the number of columns. And I represents the row subscript to which we want to find the address, and LB is the low bound subscript. What is the low bound subscript? The low bound subscript is 0. Next, J. J is nothing but the column subscript to which we have to find the memory address. So, now let's write what is base of A represent. Base of A is nothing but the base address of the first element W represents words per memory location. N represents number of columns and I represents the row subscript to which address is to be found. And LB represents the lower bound subscript and J represents the column subscript to which address is to be found. Yes. So using this formula, now let's find the memory address of location A of 1, 0. A of 1, 0. So substitute for this formula, that is location A of, what is the value of I? The value of I is 1 and the value of J is 0 is equal to base of A. So what is the base address? The base address was 2001. The address of the first element. So the address of 10 is 2001 plus word. W represents word per memory location. So the value of W is 1. We are storing only one word per memory location. What is the value of N? The N represents the number of columns. So how many columns are there in this matrix? We have 3 rows and 3 columns, right? Hence, the value of N is 3. What is the value of I? The value of I is 1. That is the row subscript to which we have to find the address. 1 minus LB, lower bound address. What is the lower bound address? The lower bound address is 0 plus J minus. So what is J? J is nothing but the column subscript to which we have to find the address. So the value of J is 0 minus lower bound address. What is the lower bound address? That is 0. (2001) plus 1 into 3 into 1. 1 minus 0 is 1. 3 into 1 is 3 plus 0 minus 0 is 0. 2001 plus 1 into 3 is 3. So 2001 plus 3 is 2004. So this is the memory address of location A of 1 into 0. So check whether it is correct or not. So according to the row major order representation, the address of 10 is 2001 and address of 20 is 2002, address of 2003, address of 40 is 2004. So what I have given, we have to find the memory address of A of 10. A of 10 memory address is 2004, hence what we have calculated is correct. So this is how we are going to represent the array elements in row major order, as well as we are calculating the address of any element in an array. Next is column major order. So what is column major order? In column major order, the elements of first column are stored in sequential memory location, and next the second column elements are stored, and so on. So consider an array A of 3 cross 3. So this is the number of rows and this represents the number of columns. The first index represents the number of rows and the second index represents the number of columns. So the array elements are 10, 20, 30, 40, 50, 60, 70, 80 and 90. As it is 3 cross 3 matrix, we can store 9 elements in the matrix. So now let's see how to represent the array elements in column major order. In column major order, first we are going to store the elements of first column, then the second column and then the third column. So the first column elements are 10, 40 and 70. Then second column elements, that is 20, 50 and 80. Then the third column elements, that is 30, 60 and 90. So let the memory address of first element be 2001. So the position of 10 is A of 0, 0. The position of 40 is A of. The position of 70 is A of 2, 0. The position of 20 is A of 0, 1. The position of 50 is A of 1, 1. The position of 80 is A of 2, 1. Position of 30 is A of 0, 2. Position of 60 is A of 1 cross 2. And position of 90 is A of 2 cross 2. So these are the positional values of the elements. Now let's see how to calculate the memory address of any element in an array. So there is a formula to calculate the memory address of any element in an array using column major order. That is location of A of I j is equal to base of A plus W into I minus LB plus J minus LB, M into J minus LB. So in this formula, the base of A represents the base address of the first element. And W represents number of words per memory location. And I represents row subscript to which address is to be found. LB represents lower bound subscript. And M represents the number of rows in an array. Number of rows in a matrix. And J represents column subscript to which address is to be found. So using this formula, now calculate the memory address of location A of 2 cross 2. So this is the value of I. The first index represents the value of I, that is the number of rows in a matrix, and the second index represents the value of J, that is the number of columns in the matrix, is equal to base of A. What is the value of base address of the first element? The base address of first element is 2001. 2, 0, 0, 1 plus W represents words per memory location, that is 1. What is the value of I? I represents the number of, that is row subscript to which address is to be found. That is, what is the value of I? The value of I is 2. 2 minus LB. That is low bound subscript. What is the low bound subscript value? That is 0. Plus M. What is M? M represents the number of rows in a matrix. So, how many rows are there? There are 3 rows. That is 3 into J. What does J represents? J represents column subscript to which address is to be found. So, the value of J is 2. 2 minus LB. What is LB? Lower bound subscript, that is 0. One into 2 minus 0 is 2 plus 3 into 2 minus 0 is 2. So, 2, 0, 0, 1 plus 1 into 2 is 2 plus 3 into 2 is 6. So, 6 plus 2 is 8, 8 plus 1 is 2009. The memory address of location of 2 cross 2 is 2009. Check whether it is correct or not. A of 200, the memory address of A of 200 is 2009. Hence it is correct. So, this is how we are going to calculate the memory address of any element in an array using column major order. So, this type of problems you will get for 3 marks. So, you can expect questions like give the memory representation of 2-dimensional array for 3 marks. So, in that case you have to write both row major as well as column major order. In sometimes they will ask you to find the memory address of any element like this using row major formula or column major formula. Next, let us see the advantages, disadvantages and applications of arrays. So, what are the advantages of arrays? The advantages of arrays are, using arrays we can represent the same type of elements using a single name. And arrays are used to represent other data structures like heaps, linked list, stacks, queues, etc. 2-dimensional arrays are used to represent the matrices. 2-dimensional arrays are used to represent matrices. The matrices. So, using arrays we can represent the same type of elements, using a single name, and we can represent other types of data structures like heaps, stacks, queues, etc. and using two-dimensional arrays we can represent the matrices. So, these are all the advantages of matrices. When it comes to disadvantages of arrays, in advance we should know how many elements we are going to store. In advance we should know how many elements we are going to store. How many elements we are going to store in an array. An array is of static nature. What is the meaning of static nature? It means it is of fixed size. So, as array is of fixed size, we cannot increase or decrease the size of an array. That is called as static nature. We cannot increase or decrease the size of an array. Since array is of fixed size, if we have already allocated memory location more than the requirement, then it will be wasted. And if I want to store elements more than the memory location, then it will create problem. So, that is one of the disadvantages of arrays. For example, the array size is 10. So, here I can store only 10 elements. So, if I store only 5 elements in an array, then the another 5 memory locations get wasted. And if I want to store more than 10 elements like 12, then I cannot store 12 elements in an array. It will create a problem. So, here the array elements are stored in consecutive memory locations. Array elements are stored in consecutive memory locations. Hence, the insertion and deletion is difficult and it is of time consuming. So, these are all the disadvantages of arrays. Next is applications of arrays. Applications of arrays. Arrays are used to represent other data structures like heaps, stacks, queues, etc. And using arrays we can represent matrices and vectors. We can represent matrices and vectors. And in many databases whose one-dimensional elements are also records. So, these are all the applications of arrays. So, in this session we have studied what is two-dimensional array and how to represent the two-dimensional array using row major and column major order. And using row major and column major order, we learned how to find the memory address of any element in an array. And also we studied advantages, disadvantages and applications of arrays. Thank you.